Alright, let's look at the homework 5.4, 5.5, problem number 14. Alright, so we want to sketch the region bounded by these two guys. Alright, so let's do the easy one, x squared. So we can do that. So that's a parabola. And it's going to go through the origin. So vertex is going to be origin. So it's going to be 0, 0. Right? Then the other point, you can try 1, 1. When x equals 1, x squared, 1 squared would be 1. So 1, 1 would do it. So try 1, 1. Alright? So that's the second parabola. Alright, first parabola. Vertex is going to be at 0, 4. So we're going to put the 0, 4 there. So x is 0. It's 4. Alright. Then it's going to go through. For example, let's try 1, 3 or something like that. So we're going to try 1, 3. Alright. Alright, so that's that. Then you can see that the intersection, let's see, the region bounded by these two is going to be right here. So we have that. Alright, then find the region. Alright, so it looks like the first guy is the top curve and the second guy is the bottom curve. Alright, so let's do that. Alright, so first we have to find an intersection of these two guys. So we have to set them equal to each other. So we can say x squared must be equal to 4 minus x squared. Right? Then we can add x squared to both sides. So you have a 2x squared is equal to 4. Right? Then we can just divide through by 2. You have x squared is equal to 4. Right? And then we can just take the square root. So x is equal to, oh, actually, I messed it up. So this is actually 2, right? 2. Alright, so if you take the square root, you have to consider the positive or negative square root of 2. Alright. So the area, of the region, so this is going to go from, negative square root of 2 to positive square root of 2. Right? Then the top curve is the 4 minus x squared. So top curve 4 minus x squared. Then you subtract the bottom curve is x squared. Right? dx. Alright, so this is going to be equal to, right? So clean up a bit. So you have a negative square root of 2 to positive square root of 2. And it's going to be 4 minus 2x squared dx. Right? And one thing we can do is that this function right here is an even function. Right, so we can use that trick. Instead of go all the way from negative square root of 2 to positive square root of 2, we can just find the half of it, which is 0 to square root of 2, then multiply by 2. Right, then you have this function 4 minus 2x squared dx. Right, so find the antiderivative. Right, so let's see. Actually, I'm gonna pull out the 2 here. So pull out the 2 from 4 and the 2 here. So it's gonna be 4. Right, then you have an integral from 0 to square root of 2. Then you would have 2 minus x squared dx. Alright, then let's evaluate it using fundamental theorem of calculus. Antiderivative of 2 is 2x. Antiderivative of negative x squared would be negative x cubed over 3. And you're going from 0 to square root of 2. Alright, so I'm going to go up here. Alright, so we have 4. And then plug in, right, square root of 2, so it's a 2 square root of 2, right? And plugging here, so it's going to be square root of 2 cubed is 2 square root of 2 again, so it's a minus 2 square root of 2 over 3. And if you plug in 0, so it's going to be minus 0, so this is going to be that, right? So this is going to be, so the 6 square root of 2 over 3, so that's 4 square root of 2 over 3, and you're multiplying by 4. So which is going to be 16 square root of 2 over 3, right? So that's the area of the region, all right? So let's type it in. All right, the answer we found was, let's see, 16 and square root of 2, and then divided by 3. I forgot. All right, divided by 3. Yep. 3. All right. All right, let's check the answer. All right, it came back. Looks like we got the region correctly and the area correctly. All right, that's it. I hope that this was clear.